Good morning. I am Devasena. In this lecture, we are going to discuss about Dynamic Host Configuration Protocol, in short DHCP. This topic is present in the subject Wireless Networks. Let us discuss about Dynamic Host Configuration Protocol, that is DHCP in short. Dynamic Host Configuration Protocol is an automatic configuration protocol used on IP networks. DHCP allows a computer to join an IP-based network without having a pre-configured IP address. DHCP is a protocol that assigns unique IP addresses to devices, then releases and renews these addresses as devices leave and rejoin the network. If a computer is connected to a network, DHCP can provide it with all the necessary information for full system integration into the network. Example, addresses of a DNS server and the default router, the subnet mask, the domain name and an IP address. Providing an IP address makes DHCP very attractive for mobile IP as a source of care of address. Let us see the basic DHCP configuration. This is the representation of the Dynamic Host Configuration Protocol. This is a client-server model. This is indicated here. DHCP is based on a client-server model as shown below. This is the representation of a DHCP protocol mechanisms. Here we have considered one client and two servers. The conversation is going to be happen between a single client and two servers. Let us see this in detail in further slides. Consider this diagram. Here, DHCP client sends a request to the server using DHCP Discover in this example, to which the server responds. A client request using MAC broadcast to reach all devices in the LAN. The client broadcasts a DHCP Discover into the subnet. There might be a relay to forward this broadcast. In this case shown, two servers receive this broadcast and determine the configuration they can offer to client. Servers reply to the client's request with DHCP Offer and offer a list of configuration parameters. This is indicated in this diagram. The client can now choose one of the configurations offered. The client in turn replies to the servers accepting one of the configurations and rejecting the others using DHCP Request. This is indicated in the diagram. If the server receives a DHCP request with a rejection, it can free the reserved configuration for other possible clients. This is indicated here. The client is accepting one DHCP offer from one server and it rejects the other offer from the server. This is indicated in this diagram. The server with the configuration accepted by the client now confirms the configuration with DHCP pack, that is indicated in this diagram. This completes the initialization phase. If the client leaves a subnet, it should release the configuration received by the server using DHCP Release. This is indicated in the diagram. Now the server can free the context stored for the client and offer the configuration again. In configuration, a client gets from a server is only leased for a certain amount of time. It has to be reconfirmed from time to time. Otherwise, the server will free the configuration. This timeout of configuration helps in the case of crashed nodes or nodes moved away without releasing the context. DHCP is a good candidate for supporting the acquisition of care-of addresses for mobile nodes. The same holds for all other parameters needed, such as addresses of the default router, DNS service, the time server, etc. A DHCP server should be located in the subnet of the access point of the mobile node, or at least a DHCP relay should provide forwarding of the messages. RFC 3118 specifies authentication for DHCP messages so as to provide protection from malicious DHCP service. Without authentication, a DHCP server cannot trust the mobile node and vice versa. Thank you very much for listening to this lecture. For further updates, kindly subscribe this channel. If you like this video, means you can share this video to your friends.